Good afternoon, everyone. Today, we are going to study the measure method for asphalt mixture design. This is Dr. Qiaodong, currently working as a professor in the School of Transportation in Southeast University. So today, we are going to study the background and the procedures how to utilize Marshall method to design a quality asphalt mixture for our pavements. So firstly, let's talk about some background of Marshall method. Back in World War II, when the U.S. Army Corps of Engineers want to design a better asphalt mixture for larger and larger military aircraft, like this B-17 bomber here, a man called Bruce Marshall from Mississippi Highway Department invented the Marshall test and the Marshall method. It is currently the most widely used method in the world to design asphalt mixture. The objective is to find the best mixed proportion for best pavement performance. So the Marshall method or Marshall test generally includes three aspects. The first, they have a Marshall mold and a Marshall hammer to help us prepare specimen. The second is the equipment used to measure the specific gravity of mixture and rice samples. The third is called a Marshall stability tester, which help us to find the strength and the deformation of asphalt mixture. So the design method generally includes two steps. First step, select the material. Select a good quality asphalt and aggregate. Second step, determine optimum asphalt content. How to do that? We have three steps. So the first step is to prepare trials with different asphalt content in the lab. Use a hammer and mold. Second step, we run laboratory tests to determine volumetric and the strength, those key characteristics. The third step is to pick up the content that gives best performance, that satisfies the best performance. So after Marshall developed the Marshall method, the U.S. Asphalt Institute standardized this method. It generally includes 7 steps. And China imported this method, made several revisions. It also includes 7 steps. Next, we are going to go through the whole procedure step by step. So first step, mixed type selection. We have to select proper asphalt mixture type according to the road grade, the layer of the pavement, climatic, and traffic. Second step is material selection. Firstly, we select proper asphalt. We select proper asphalt grade based on climatic, road grade, track pavement type, etc. Then we select quality aggregates according to some mechanical and physical properties of those aggregates, like angularity, crushing value, abrasion requirements. The third step is the gradation design. That is to find the proper gradation for our mixture according to the requirements of the road and the aggregates that we have. This table recommends the gradation for asphalt mixture with different nominal maximum size. For example, if we have want to design a mixture which has 25 millimeters nominal maximum size, this table tells us the range of the passing percent at each sieve. So here is step 4, specimen preparation and a specific gravity test. In step 4, firstly, we prepare specimens. In the lab, we preheat the aggregates in a bowl and add hot asphalt. We mix them until aggregate is well coated with asphalt film. Then we place the mixture in the Marshall mold use a Marshall hammer to prepare Marshall specimens. Here, I have a question. How many groups of asphalt content do we need to prepare? And for each group, how many samples do we need to prepare? In China, we prepare at least 5 groups of asphalt content. And for each asphalt content, we make 5 samples. Next, we are going to measure the maximum theoretical specific gravity. To do that, we firstly prepare rice samples. We use our hand with glove on to smash hot mixed asphalt mixture into small particles to drive all the air voids from those particles. And then we use the vacuum bowl to remove the air. We measure the weight, the dry rice sample, the weight of the bowl in the water, the weight of the bowl and the sample in the water. We can calculate GMM. So I have another question. For the 5 groups of asphalt content mixture, how many GMM we need to measure? The answer is only 1. Why? Because according to the volume properties of asphalt mixture, we can calculate the effective specific gravity of asphalt mixture. According to this GMM, then we can calculate the GMM for all the rest of 4 groups using this equation. Next is to measure the bulk specific gravity of the samples. We use the scale that can measure both the dry weight and the weight on the water, and use this equation to calculate that. The 5th step of step 4 is to calculate volumetric characteristics. The first volumetric characteristic is VTM, or Weir voids. It's the voids in total mix, which is the volume of the air over the volume of the mixture. The second one we call VMA, which is the voids in the mineral aggregate, which is the volume of the air and the free asphalt over the volume of the total mix. The third one we call VFA, is the void filled with asphalt, is the volume of free asphalt over the volume of VMA. Step 5 is to do the Marshall stability test. We firstly put the specimen in the hot water bath at 60 centigrade for at least 2 hours. Then we apply a lateral force on the side of the specimen. The loading rate is 51 millimeters per minute. And from this test, we can obtain a load deformation curve like this. The Marshall stability is the maximum load the sample can bear. And the flow value is the corresponding deformation. With those volumetric characteristics and the mechanical characteristics we obtain from Marshall test, we can now to find out the optimum asphalt content. The method is to check those characteristics against the performance requirement of Marshall stability, flow value, VTM, VMA, and VFA. So this 2 tables give us the requirements for different asphalt mixtures we need. Here, I will use an example to teach you how to find the optimum asphalt content. For example, we have 5 groups of asphalt content, and we have the stability and the flow value. We also calculate the VTM, VMA, and the VFA. And here shows the requirement for different characteristics. What shall we do? We follow these 4 steps to find the OAC, which is the optimum asphalt content. Firstly, we draw the chart of asphalt content versus those characteristics. Secondly, we calculate OAC1 based on the asphalt content corresponding to maximum density maximum Marshall stability, average of design VTM, average of design VFA. Thirdly, we find OAC2, which is to find the range, the average of the range of asphalt content that satisfy all the performance requirements. And the first step is to find the final OAC, which is the average OAC1 and OAC2. Now, let's see how to find OAC1. So firstly, I have the chart of asphalt content versus the 4 characteristics. So firstly, max density, we can see that 6%. Max stability, that's 4.5%. And remember, we want Marshall stability higher than 8 kilonewton. So the range for asphalt content is from 4 to 5.5. And for the VTM, we want the VTM between 3 and 5, and the range of asphalt content is from 4.3 to 5.1. And the average VTM, which corresponding to 4% air voids, is 4.6. So similarly, for VFA, we don't want them between 55 and 70. The range of the asphalt content is from 4 to 5.3, and the average, and the asphalt content corresponding to the average VFA is 4.6. So now I have the 4 values, and we take an average of these 4. That's how we find OAC 1. For OAC 2, we need to check another 2 characteristics. Remember, in OAC 1, we already checked 4, and we know the range for 3 of them. So let's look at these 2 additional characteristics. For VMA, we want them all higher than 12. That means all the asphalt content met this requirement. For the flow value, we want them between 2 and 4. We can see that the acceptable asphalt content ranged between 4 to 5.6. If we draw the asphalt content that satisfies each requirement of the characteristics, we would find this chart showing in the left bottom corner. So we find the range of asphalt content that met all the requirements. We take an average. That's 4.6. That's OAC 2. And we take an average of OAC 1 and OAC 2. That's the final OAC, 4.8. That's our determined optimum asphalt content. So that's the end of step 6. But that's not the last. We also need to check the performance of our design mixture to make sure it met the requirement of pavement performance. Usually, we will check moisture susceptibility and the high temperature concern. For the moisture susceptibility, we are going to check if our design mixture have sufficient moisture stability. That means after moisture damage or freeze-thaw damage, the mixture still have sufficient strength. We use Marshall stability after soaking or use the freeze-thaw test to test that. For the high temperature concern, there are many types of applied loading test. We just measure how much rotting depth and the rate of rotting increment to make sure our mixture met the requirement. After we validate through these 2 or even more laboratory tests, we can tell contractors now 4.8 is your optimal asphalt content. So that's the whole procedure of Marshall stability. Thank you very much.